Right, okay. So here we are looking at question number 3 of your first chemistry practical. Now, most of you have just completed it, and this is for the benefit of those of you who could not join us to do this practical. Let me give you a few hints and tips as I do this practical and complete it with you. So, with you, you will have your reagents, and mostly you will have enough droppers to dedicate a dropper for each of your substances that you have, for each one of your solutions. Huh? Make sure that it is properly marked, Fa3, Fa6, 7, 8 we have sodium carbonate starch, right, so that's all that we have. Then you will also have your test reagents in a little bucket. Right, so everything that you need to test with for your ions. So literally the test that I showed you previously, the cations and the anions as given here, all those test solutions will be available to you. Should some of them run out, there's always available in stock solutions. At times you will also need to heat certain of the test tubes, right? So first thing is important that you know the difference between a boiling tube and a non-boiling tube. So a boiling tube will have a much thicker wall than a non-boiling tube. So for instance, those bigger tubes that you use in biology, they are not boiling tubes. They will crack, burst, break, and spill everything out. So also are some of them. I will make sure mostly, I can't 100% guarantee every time, especially with these intermittent practicals that you're doing. But please check that you have the thicker wall ones when you need to heat substances. Right. You will have a Bunsen burner, and this, I'm especially set at this stage, this is excessive. You don't need a flame like that. Especially in this practical where they said in the first point that you need to carefully and gently heat it. Then you must make sure your Bunsen burner is set relatively low. Now, this is a nice Bunsen burner because it can sit at it. If it can't sit at the Bunsen burner, you need to use a little tap to close it or make it great. Now, again, whenever we hold a test tube, we are going to use a test tube holder. It's made of wood, so be careful. It does also burn, for those of you who do not know that. Right? So do not hold the wood in the flame you're going to have a little dry. Now, when you start with your qualitative analysis, read through the whole practical first. See what you are going to do. Now, so that you don't miss something. Also make sure that you are aware of all the observations. You also have a pair of goggles with you. Please use them. It is essential because, as you would have noticed, acids and alkalis have low boiling points. You will get a little pop out of this test tube very easily. Okay, so let's read and let's start with this practical. It says, first of all, under point 3a, you have Fa3, which is aqueous hydrogen peroxide, and Fa6 is a solution containing 2 cations and 1 anion from those listed on the qualitative analysis notes. That's those script notes at the back. Step 1, 1 cubic centimeter. This is a pinky. My pinky is smaller than your pinky, doesn't matter. This is not quantitative but qualitative. What does that mean? I just want to figure out which ion is in there, not the amount of the ion. Okay? And aqueous sodium hydroxide. So here's my aqueous sodium hydroxide. I start by adding a little bit, and then until it is an excess. An excess is usually more than double. So let's do that. I start by adding a few drops, and immediately I see a color change. And I see that it is a green precipitate forming. Like you can see, there's little cloudy stuff at the bottom. As I add more, it just adds to it. It doesn't dissolve. That means it's insoluble in excess. So if you're unsure, add more. Because more is always better. Okay, so no, nothing happened. It doesn't dissolve. What does, however, happen, if I can bring it closer, you should be able to see a little browning on top there. That's happening wherever it's in contact with the air. Right, so now I'm turning to my notes at the back and I'm looking for a greenish precipitate. And I see two. I see my chromium as a grey-green, and I see my iron 2 as a green precipitate. But with my iron 2, it says it turns brown on contact with air. Okay, so it turns brown on contact with air. So this is iron plus 2. Yay, I have identified my first cation. Now, question. If I repeat this process with Fa6, I'm going to get the same result by adding aqueous sodium hydroxide. Should I repeat it with ammonia, I'm still going to get the same green precipitate turning brown on contact with air insoluble in excess. By repeating it with sodium hydroxide and ammonia, I'm not going to identify a second cation. But they say there are two. If I read my instructions further, they say, then heat the test tube gently and carefully. Whenever you're going to heat a solution or test sample, you are going to most probably release a gas. Alright, so which of my gases in my analysis notes would have cations as bases? Well, there's hydrogen, and there's the ammonium ion, NH4+. So my guess will always be to start with the one that I'm not using a wooden splint with. Because as soon as you have a wooden splint, you're going to bring in some carbon dioxide or you're going to use some oxygen or whatever in there. So I'm always going to start with my litmus test first. Now my ammonium ion I can test by testing for ammonia gas being released. Right? How do I do that? Well, by heating this, damp litmus should turn blue. Now, I know an alkali has a low boiling point, so I'm going to use some of my damp litmus paper, drape it over it, and now I'm going to heat very gently my solution and see what happens. Now, remember, I've added some sodium hydroxide, so this means that I can't put it in there, then it's going to turn blue. Look at what happened over here. I'm going to bring this closer so that you can see. Immediately where I touched it to the side, it turned blue. But also there where the gas touched it, that was released, it turned blue. So there is a basic gas that was released. So yes, ammonia was released. I'm not going to test further. Remember, you've got 10-15 minutes maximum to do this part. You need to hurry up. I'm going to guess that. I'm going to say yes, red litmus turned blue. And in my observations, I am going to use my analysis notes. I'm going to say damp red litmus turns blue. Alright? I'm going to say green precipitate turning brown in contact with air insoluble in excess. I'm going to use those words, or the wording given in there. Right, okay. First observations, cations, iron plus 2, and NH4 plus my ammonium ion identified. 4 marks, done and dusted. Ion. To the mixture obtained, carefully add 1 cubic centimeter of Fa3. Okay, so you see, realize what could have happened if I didn't read through the whole process and I thrown this out in my waste bucket, I wouldn't be able to repeat or complete my test, and I had to do it all over again. So that's why I suggest read through before anything else. Right, let's take Fa3, let's see what's happening to this. I'm adding, oh, look at that. It turns brown. It gives me a brown precipitate that form. So I know from my theory that hydrogen peroxide is a very strong oxidizing agent. I also know that iron 3 plus is this red-orange color. So the oxidation process that takes place is what they now want us to write down. And that is my Fe2 plus, right, being oxidized to Fe3 plus. So iron plus 2 to iron plus 3 plus 1 electron. That's my process taking place. Right, okay. So first 6 marks done and dusted. Let's go on to my next bit. Now, they start off by telling you which reagent you need. You need Fa1, that's potassium permanganate. That's always the purple one. You need Fa2, that's my sulfuric acid, as well as Fa7 and Fa8. Right, what are we going to do? We're going to do 3 different tests according to this. Test 1, test 2, test 3. We're doing it with 7 and 8. So what I would do immediately, I would prepare my test tubes. I'm going to take my flame just out of the way here quickly. I'm going to say, okay, there is Fa7, Fa8, test 1, Fa7, Fa8, Fa7, Fa8. I've got my test tubes. Let's see what you need to do. To 1 cubic centimeter of each one of those solutions for 7 and 8, the first test. Add a small spatula of solid sodium carbonate. Okay, so here's my solid sodium carbonate, and I'm looking for my spatula. It's somewhere good. So make sure that you have the equipment before you start and ask the invigilator, your supervisor. Right, Fa7, let's add. Nothing really happens. Let's stir. The white is dissolving and it's giving me a clear solution. There's no real reaction. How would I see a reaction? Well, color change, fizzing, something like that would give a reaction. This only dissolve. And you can write dissolve or you can write no change. But let's see what happens. There's my spatula full, I'm adding. Now that is a reaction. There's fizzing happening. They only ask for observations. So fizzing, and it gives me a clear solution. Okay? Fizzing, or you could say effervescence, or you can say bubbling. That's my observation. Done and dusted. Written in. Test 2. Test 2 is separate from test 1. To 1 cubic centimeter of Fa7 and Fa8, add equal volumes of Fa2. Fa2 is sulfuric acid. Right, so here's my sulfuric acid. And I'm going to use 7 and 8. Here we go. 7, there's my sulfuric acid. And now equal volume, so I'm filling it up to my second line in my dropper. I add it. Second line, add it. Alright, equal volume, I need to use my there. Permanganate, equal volume, so again to my second line, adding it. Oh, it gives me a brownish solution with Fa7, and, well, a purple color with Fa8. So purple to purple, I would suggest no change. But with my other, it gave me a brown solution. No precipitate, solution. One must specify either solution or precipitate. Okay? I'm not done. Those were my first observations. Then, after the dotted line, they say add a few drops of aqueous starch. Okay, let's do that. So, few drops Fa7. Oh, look at that. It's giving me a blue-black precipitate. Let's do it for my other one, and there's no change. How do I know it's a precipitate? Well, if I bring it closer, and you see on the test tube wall, you can see little granules. You can also see at the top, there's little granules starting to form and fall to the bottom. I can shake it, and next to the wall, on the side of the wall, you can see it. So a blue-black precipitate. Now, in your nice knowledge thereof, you would find that a brownish solution turning blue-black is the test for iodine solution. Okay, so there's iodide ions in there. This is immediately my conclusion, because identify, if I look at my question, the anion in Fa7, right? Iodide, fantastic. Right, Fa8 didn't do anything. Although, in my first test, Fa8 fizzed and bubbled with a metal carbonate. Right? Let's go to test 3. What do they say? They say, to that 1 cubic centimeter of solution, add a few drops of silver nitrate. Okay, so silver nitrate. Where's my silver nitrate? My silver nitrate. And now I need to add a few drops of light. Right, so to Fa7 and to Fa8. Now, there's a nice color difference in there, isn't it? The one is pale yellow and the one is white. I'm not done with my test, but my suspicions were confirmed. Fa7 has an iodide ion in it. And now this test tells me, well, Fa8 will probably have chloride. How do I test for that? I use ammonia, aqueous ammonia, and that's this last step in this. Add aqueous ammonia. Now, if this is, as I suspect, chloride and iodide, my chloride will dissolve, but my iodide will not. So adding to Fa7, the pale yellow stays pale yellow. Adding to Fa8, oops, it dissolved. It is chloride ions. Fantastic. So now I've done my observations, I've written them down, I've identified my anion in Fa7 as being iodide. I've identified Fa8, well, it has a chloride ion in it. But now they say carry out one further test to confirm the identity. Now, we can do various things. What is my suspicion? Well, chloride in there, and it had a reaction with sodium carbonate. So a gas was released. I know from our chemistry knowledge that an acid plus a metal carbonate releases a gas, carbon dioxide. I can now do a test and say, okay, let's test this with an indicator. And this is why In the beginning, there was universal indicator paper in there, and then Daniel got how to do it. Okay, so if I did this, my reagent would be universal indicator paper, indicator, observation turns red, meaning it's an acid, so hydrochloric acid. There were also some magnesium strips. You could add a magnesium strip, and it would also react like fizzing and bubbling. A test that Katie and Cherie and Richard just did was a test for hydrogen gas. I convinced them to do it. It's the more, I wouldn't say hazardous one, but it is sometimes a bit harder to do. You need to remember that hydrogen gas is a very light gas. So it will pop when you have a lid split to it. Let's see if I can repeat it. I'm not going to do it too many times. I'm going to try and do it. And again, this is an acid. We don't want to excessively heat it. I want to carefully heat it. Actually, you want to have small bubbles at the back coming out. I'm going to wait with my split until I see those bubbles. So just always be patient. Moving your test tube over there would spread the heat. It will also disperse it on the test tube, but also within the liquid. You would see by doing that, you'll get the little bubbles going. You would see some condensation on there. No bubbles yet. Okay, so I'm going to try this now because I see there's some condensation forming. Let's keep that there. Hopefully. I hope I have the right solution. And I hope I can impress you by doing it. Don't want to push it in, it should come out. Oh, there it goes. So that was too much. Right. So that's the reason why I say be very careful. Don't aim it at someone. It didn't even make the small bubble. It just popped out of the test tube. So please don't aim that. Oh, well, there we go. That's, now we can get to no popping sound. Right, so I'll let you hear how it sounds when we add some iron filings to it. Let's perhaps do it this way. If we add some of the Fa8 more to it. And now, since it is a bit hot, I should actually have kept the glass and water on. So it's a bit too volatile in that sense. Perhaps the acid is too strong. I can't even recall what the concentration was. We can do the following. Remember, if we add a metal to the acid, hydrogen gas will also be released. So let's quickly see it here. Perhaps this can give us some clue to it. So, adding my metal strip in it, there's my gas being produced, and perhaps this is going to give me enough gas to get to. Did you hear that? That's going to give me my test. So eating it, probably not the best idea. This was the magnesium strip, if you want to hear it again. So that's the nice pop sound. So heating it is not a good idea, acid heating. Let's try it again. You heard it again, hopefully. But now that is being used up. So that's my positive test for hydrogen gas being produced. Right. Hope you guys enjoyed this. Good luck.